Hello, my dear students. Welcome to my class Astrophysics. Today's topic is uniform circular motion. It is also a two-dimensional motion, just like projectile motion. The projectile motion generally taken place in a particular plane, but circular motion they can be taken place at any plane, maybe horizontal, maybe vertical, or maybe any other plane. That means it is another example of two-dimensional motion. Initially, today we have learned the different terms related to this uniform circular motion, also for the non-uniform circular motion. First of all, what is the meaning of the uniform circular motion? When a particle moves along a circular path with a constant speed, it covers equal distances along the circumference of circle in equal intervals of time. Then the motion is said to be uniform circular motion. Here you should notice one thing, that we are saying constant speed, we are not saying the constant velocity. Why it is so? Why we are not saying the constant velocity? Because here, if you look this figure diagram carefully, at the different point, the direction of velocity will be different, and that is along the tangent. There is a continuous change of the direction of the velocity. In uniform circular motion, speed of the particle remains constant, but the direction of motion changes continuously, so the velocity of the particle is different at different points. Because the velocity, it is a vector quantity, and you know that vector quantity has two, that is, it has magnitude and it has also directions. If there is any change in the magnitude or any change in the directions or both, there will be change of velocity. And when the velocity changes, let us suppose what will happen, then that motion will be known as non-uniform motion. That means accelerated motion. At each position, velocity vector v is perpendicular to the radius vector r, because radius vector and tangent always perpendicular. Therefore, the velocity that is always perpendicular to the r vector, and the velocity of the particle changes continuously due to the change in direction of motion of the body. So the uniform circular motion is accelerated motion. That means since the velocity changes always due to the change in the directions. So when velocity changes, that is nothing but the accelerated motion. So if you asked, is uniform circular motion a uniform motion? Obviously, it is not a uniform motion. Be careful about it. The uniform circular motion is accelerated motion. It is due to the change of the direction of velocity at each and every point during the movement in a circular path. Now, one term, that is the angular displacement. What is the angular displacement? The angular displacement of a particle moving along a circular path is defined as the angle described by the particle, that is radius vector, in the given interval of time. In this figure diagram, here the initial point, that is at t is equal to t0 time, the position of that particle or the object, that is point A, and after time t it will reach the point B. At that time there is a linear distance and traveled by the object. At the same time there is an angular displacement, that is delta theta or theta, and this as the angle described by the particle or radius vector, this angle is known as the angular displacement, and this angle AOB angle is theta is called angular displacement. And we know from our previous knowledge that arc of any circle, and which makes an angle at the center of the circle, and that will be theta, and theta is the length of the arc divided by radius of that circular path. Obviously, when we measure the radius, angle in the radian unit in SI system, it is a dimensionless quantity, this theta. So what is the angular displacement? The angle traced by radius vector or described by any object in time interval delta t. And what is the relationship between the linear distance travel, that is the AB, and the angular displacement, that is the theta? The theta will be length of the arc divided by radius r, and it is only when valid, when the theta is measured in the radian, and it is that's theta, the angular displacement, that is one dimensionless quantity. And from this equation, we already define what is 1 radian. And when we want to define 1 radian, we have to take AB equal to R. That means when the length of the arc is equal to radius of the arc, what is the angle subtended by that arc at the center, that is known as the 1 radian. Now second term is the angular velocity. Angular velocity of any object in circular motion is the time rate of change of angular displacement of the object. Just similarly to the linear velocity displacement by time taken, here angular velocity, that will be angular displacement by time taken. SI unit of angular velocity, that will be radian per second, and it is written in this way, rad per second. Obviously dimensional formula, that will be 1 by T, that is m naught L naught T minus 1. It is the angular dimensional formula for the angular velocity, and dimensional formula for the angular displacement is the m0 L0 T0. It is a quantity, dimensionless quantity, but we are using some unit also here rather than the no unit. What will be the directions of the angular velocity, because it is a vector quantity? Theta, angular velocity, angular acceleration. In future you will get the angular momentum, torque, all these are axial vectors. You already know it. And therefore the omega, that will be acting along the axis of the circular path, and that axis is always perpendicular to the plane of the circular path. Now there are two directions of the axis. One is the upwards or outwards, another direction will be downwards or inwards. And what will be the direction of the omega? And that depends upon the sense of rotation of the object. If the object is rotating in anti-clockwise order, then the directions of omega, that will be along the axis and upwards or outwards. And if the sense of rotations or order of rotation of the object or of the particle in clockwise order, then the omega will be vertically downwards or inwards. According to situation, you have to use the language. Let us consider a point object moving in a circle of radius r. In this example, having center O, it is center O, moves from point A to point B in time delta t, such that its angular displacement is delta theta. Now, angular velocity, that will be angle traced by time taken. And when you write angle delta theta by delta t, that is nothing but the average angular velocity. But if you want to find out the instantaneous angular velocity at, that means angular velocity at any instant, then we have to take the time interval is very small, that means delta t tends to 0. And omega factor will be limit delta t tends to 0, delta theta by delta t, that is equal to d theta by dt. That means when you write a d theta by dt, it is always understood that change in the time interval is very small, and it is nothing but instantaneous one, and it is also known as the derivative of the theta with respect to time t, differential coefficient of theta with respect to time t, or rate of change of theta with respect to time t. And when we write delta theta by delta t, that is average one, and when you write d theta by dt, this is the instantaneous angular velocity at that moment, at that point. Angular velocity is a vector quantity, and its direction is given by right hand screw rule. That means if you take the right hand thumb rule, it is also known as the right hand, and the curl of the finger gives the order or sense of rotations. Then thumb, that is perpendicular to the plane of rotations, that is along the axis, that gives us the directions of the angular velocity omega. So if the order is the anti-clockwise, then thumb will be upwards, and order is the clockwise, then thumb will be downwards. And that means with the help of this thumb rule, even if right hand screw rule or right hand corkscrew rule, as you like to say, you can find out the directions. And it is simple, very simple. When the anti-clockwise, that is upwards or outwards, and when it's the clockwise, that is the downwards or inwards. You can remember it also. And upwards or anti-clockwise order, that is taken in the positive order, and clockwise order, that will be taken in the negative order in all cases, both in physics, mathematics, etc. Direction of angular velocity is along the direction of the d theta. That means the direction of the d theta is also along the axis. When the rotation of the point object is in anti-clockwise order, then the direction of omega is along the axis of circular path directed upwards or outwards. But if rotation of the point object is in anti-clockwise direction, then the direction of omega is along axis of the circular path directed downwards. That means it is very easy to remember that directions of any axial vector that will be along the axis, and there are two directions, either upwards or outwards or downwards or inwards. There are only two directions. That means answer will be only two, either outwards or upwards or downwards or inwards. Then if the sense of rotation for all type of axial vector sense of rotations, if it is anticlockwise, that is taken in the positive order, the direction will be outwards or upwards, and the sense of rotation is the anticlockwise, then it will be negative one, negative order, and that will be downwards or inwards. Now relation between linear velocity and angular velocity. Let us consider that a particle is moving in a circular path of radius r with linear velocity v and angular velocity omega in anti-clockwise directions or order. The particle moves from point A to point B in time delta t such that it covers linear distance delta s along the arc AB. Now, from our previous knowledge, we know that a delta theta, that is angle subtended by this arc at the center, arc length is the delta s, that is delta theta is delta s divided by r. Obviously, the delta theta angle, it is measured in the radian one, dividing this equation both sides by the delta t, because in time delta t there are two types of displacement. One is the angular displacement delta theta taken place, another is the linear displacement delta s also taken place. Therefore, dividing this equation 1 by the delta t, we get delta theta by delta t equal to 1 by r delta s by delta t. And if we, it is the average velocity, and if we want to find out the instantaneous velocity, then we have to take the delta t tends to 0 on both sides by taking the limiting value, that is delta t limit delta t tends to 0 delta theta by delta t, which is equal to 1 by r limit delta t tends to 0 delta s by delta t. And you can write now it is d theta by dt, and you can write it is the ds by dt, and these are nothing but the instantaneous omega, that is angular velocity. Here omega, it is a Greek letter, it is used to denote the angular velocity, and r is the constant obviously for this circle, for a particular circle, and the value of r radius is constant. And now v, the v omega is the 1 by r whole into v. What is this? Now omega is the angular velocity, v is the linear speed at any point. A point, that means instantaneous means at any point or at any instant. What is the relationship between the v, that is the v equal to omega into r? It is a very useful formula for any type of circular or rotational motion. V is the omega r. That means at the same time the particle have two types of velocity, one is the linear, another is the angular. What is the relationship between magnitude of this v and omega, that is the v equal to omega into r? Already we have s is equal to theta into r. Here we get s month of linear distance travel, and here we get v is equal to omega into r, where omega is angular velocity, v is the linear speed at that point. Now if we consider the velocity vector, then what will be the vector form of this equation? That is the v vector, that will be omega cross r vector. Now what is the direction of the v vector at any point? That will be along the tangent, we already know, and in our different practical experience we already get the velocity of any particle in a circular path at any point, that will be along the tangent. And how can we logically prove it along the tangent? Now with the, if we take this type of circular motion, let us suppose one particle is rotating in anti-clockwise order at any time, that is point A, and after time delta t, the position of that particle is point B. Therefore, delta r is the displacement. Therefore, velocity will be along the displacement velocity direction. Average velocity between A to B, that will be directed along the AB. And for instantaneous velocity, if we take the delta t very small, then in this triangle, AOB triangle, this angle, that is the OA B, this angle tends to infinity, because when delta t tends to 0, B moves towards the point A, and gradually the AB that will become perpendicular to the radius vector R. AB tends to become perpendicular to OA. So that is, OA means radius vector at point A. So AB is along the tangent. AB is nothing but the direction of the displacement. Therefore, the velocity that will be along the direction of the displacement, and that will be along the AB, which is now tangent to the circular path at point A. Hence, the velocity at point A is directed along tangent to the circle at point A along the direction of motion. For a given angular velocity omega, linear velocity, and v is proportional to its distance from the center. We can say from this equation, when omega is a constant, if r increases, that means radius increases, v will increase. And in this case, we can easily understand this now. V equal to omega cross r, v is along the tangent. We can logically prove it, how it is along the tangent. Now omega, that is along the axis, and that is the perpendicular to the plane of circle or plane of rotation, and r is on the plane of rotations. Now if the plane of rotation is horizontal plane, and if we consider a vertical plane that which contains both omega and r, that means if we consider one vertical plane which contains both omega and r, then v will be perpendicular to that vertical plane, and that will be along the tangent. Now we can write now the v vector is equal to omega cross r vector. Angular acceleration. Let us suppose the motion is angular, circular motion is not uniform motion. Then there will be angular acceleration. Angular acceleration of an object in the circular motion is the time rate of change of angular velocity of the object. That means when there is any change in the angular velocity. One example you can consider, when you just start the electric fan by tapping the switch, and then initial velocity omega 0, and gradually omega increases, and when omega increases, we can say that there is an angular acceleration because angular velocity changes. If delta omega is change in the angular velocity of the object in time delta t, then the average angular acceleration, that will be delta omega by delta t. And this angular acceleration, it is written by or denoted by the alpha, and we are taking, it is also a vector quantity, but axial vector, that is obviously along the omega delta omega. Instantaneous angular velocity is the limiting value of average acceleration when the time interval approaches 0. If you asked what is the instantaneous one, then you have to take the limiting value. That means you have to consider delta t tends to 0. Now alpha equal to limiting value delta t tends to 0, delta omega by delta t, and that is nothing but d omega dt. It is the formality. You can also write the instantaneous value directly d omega dt, because it is always understood that dt means very, very small time interval, and that means when you write d omega dt, it is nothing but instantaneous acceleration at that moment or at that position. Now alpha is the d omega by dt. For alpha vector will be d omega vector by dt. SI unit of angular acceleration obviously radian per second square, radian per second square. How it is obtained? Now omega is the radian per second divided by second, that is radian per second square. Dimensional formula will be m0 l0 t minus 2. It is the dimensional formula of angular acceleration, and we can also write in the different way. Omega is the d theta dt, we know, and alpha is the d omega dt. Therefore, when a particle rotates about an axis with uniform angular velocity, obviously then d omega dt, uniform angular velocity means omega is the constant, d omega dt 0, that means alpha will be 0. So angular acceleration is 0 when angular velocity of particle is uniform or constant. Now, relation between linear and angular acceleration. That means when the particle with angular acceleration at the same time, the speed or velocity or magnitude of the velocity also increases when omega increases. That means there is linear acceleration also. And what is the relationship between linear acceleration and angular acceleration at the same moment? And already we have the equation v the omega. Now differentiating both sides with respect to time in this equation, dv dt, that will be ddt of omega r. R is the constant, therefore dv dt, that will be d omega dt into r. And dv dt is nothing but the instantaneous acceleration, linear acceleration at that point. And alpha, it is d omega dt, it is denoted by alpha, angular acceleration into r, or a is equal to alpha into r. Already we have v is equal to omega into r, s is equal to theta into r. These are similar type of equations. And linear acceleration is the angular acceleration into r. Linear velocity is the angular velocity into r. And s is equal to theta into r. That means linear distance travel is equal to theta into r. Similarly, you can memorize it. A is also a vector quantity, alpha is also a vector quantity, and if we consider radius vector, then in the vector form this equation will be a vector will equal to alpha vector cross r vector. Here a vector and r vector both in the plane of the rotation, but a vector, it is the perpendicular to the plane which contains alpha and r, because alpha along the axis and r perpendicular to this. All these three are in this example are mutually perpendicular. That means angle between alpha and r always 90°. Therefore, we can easily write a is the alpha into r always. Now there are few terms again related to the uniform circular motion. Already we have started from this statement. What is the uniform circular motion? When a point object is moving along a circular path with constant or uniform speed, then the motion of object is said to be uniform circular motion. And the term related to the uniform circular motion, one is the time period. Time period is defined as the time taken by the object to complete one full revolution on its circular path. That means what is the time taken to complete one circular path? Since it is a periodic motion, therefore we consider the time period. Next term is the frequency. What is the definition of the frequency? For all cases, for oscillations or revolutions, the definition of frequency is the same. Frequency is defined as the number of oscillations or revolutions completed by the object on its circular path in 1 second. That means number of complete rotation or oscillations or vibrations in 1 second, that is known as the frequency. This definition, it is valid for all types of periodic motion. Periodic motion means which repeats itself after a fixed interval of time. Then what is the number of oscillations or revolutions or complete cycle, that is known as the frequency, and SI unit of frequency is the hertz. It can be also written in this way, cycle per second or per second. Now, relation between time period t and the frequency. Let us nu, it is known as the nu, it is also another Greek letter just like omega, alpha, theta. Nu be the frequency of revolution of object. Therefore, time taken to complete new revolution, that is equal to 1 second, because nu is the frequency means new number of revolutions completed in 1 second. Therefore, time taken to complete one revolution is the 1 by nu second, and it is time taken to complete one revolution on circular path is known as time period t. Therefore, t is equal to 1 by nu, or nu is equal to 1 by t. Or you can write in this way, nu into t the 1, and this relationship valid for all type of periodic motion, not only circular motion. In case of oscillatory motion or in case of any type of periodic motion, you can write this equation, time period is the 1 by frequency, or frequency is the 1 by time period, or frequency into time period always equal to 1. Now relation between time period, frequency and angular velocity. Let us, a point object is in uniform circular motion having frequency nu and time period is capital T. In one complete revolution, angle traced at its axis of circular motion is 2 pi. That means when it complete one circular path, the what is the angle subtended by that total circular path at the center is the 2 pi, or what is the complete total angle travel by this particle or radius vector, that is the 2 pi radian. And what is the time taken for it? The t time. That means when t is equal to t, the angular displacement of this particle, that is theta, equal to 2 pi radian. And what is the angular velocity? It is also one well-known equation for the uniform circular motion, that omega is the angular displacement by time taken, that is the omega is the 2 pi by t, and therefore omega is the 2 pi into nu. What is the nu? That is the frequency. What is the unit of frequency? Past second, second inverse. And what is the unit of omega? That is second inverse. Or you can say omega, the dimensional formula of the omega, there is the al0, am0, t minus 1, and dimensional formula of the frequency is also same. Therefore, this omega angular velocity, also known as angular frequency. Sometimes it will also be called angular frequency. Now we have these some basic terms. Number one, angular displacement, angular velocity, angular accelerations, angular frequency, time period, etc. etc. Now we will proceed toward the centripetal accelerations. Already we have discussed that a circular motion, even a uniform circular motion, that is not uniform motion, that is an accelerated motion. And what is that acceleration? Let us understand. Let us proceed. When an object is motion in a circle, then its velocity keeps on changing continuously due to the change in directions. Already we know it now. That means always the direction along the tangent. And when the particle is moving along the circular path, the direction of the tangent always changes at the different point. The direction of the tangent will be different. Therefore, direction of velocity always changes. As the velocity of object keeps on changing, so the motion of object is accelerated. Such accelerated motion is directed along the radius and toward the center of circular path. This acceleration acted on object is called as centripetal acceleration. That means due to the change of direction of velocity, an acceleration is produced here. That acceleration is always along the radius and directed always toward the center. Since it is always directed toward the center, therefore this acceleration is also known as centripetal acceleration. That means in any circular path, always there is a change in the velocity due to the change in the directions. And due to the change in the direction, what is the acceleration developed here or taken place here? That is always directed toward the center of the circular path and along the radius. This is known as the centripetal acceleration. Now our important task is, what will be the formula for the centripetal acceleration? That means on which factors the centripetal acceleration dependent. That is the expression for centripetal acceleration. Let us an object is moving in a circular path of radius r with constant speed v. That means we are taking the uniform circular motion when the speed is v is constant, and uniform angular velocity is omega. Omega also will be remain unchanged, uniform. At time t, the particle is at point P. Let us see the figure diagram. At time t, the position of the particle at point P. And after time delta t, that means at time t plus delta t, the position of the particle is at point Q. This one. This position of the particle, it is denoted with the R1 vectors. And the position of the point, the Q, that is denoted with the R2 vectors. Numerically, these two are same, because P point and Q point both are on the same circle, but since their directions of position vectors R1 and R2 are different, therefore we are taking different vectors as R1 vectors and other R2 vectors, and delta S is the displacement. At the point P, the velocity along the tangent, that is the V1. At point Q, the velocity along the tangent, that is the V2, and mod of V1 vector equal to mod of V2 vector, that is, let us suppose V. The speed is constant. We already considered it. Now, this angle, it is the tangent and the radius are perpendicular. Therefore, this angle is the 90 degree. This angle is the 90 degree. Now, if we consider this quadrilateral, this plus this 90, 90, 180. Therefore, this angle plus this angle is 180 degree. And this angle plus this angle also 180 degree. It is the common one. Therefore, we can say when there is a angular displacement delta theta, at the same time, what is the angle between the V1 vector and V2 vector? That is also the delta theta. Now, if we take a parallel vector that is parallel and equal to the V1, and another is the equal and parallel to the V2, that means it is OA dash, that is in place of PA vector we can write OA dash, and QB we can write OB dash, because these two are equal and parallel. Obviously, angle between the two vectors is delta theta, and it is the V1, it is the V2, V1 plus delta V, that is the V2. That means this length A dash B dash vector, that is nothing but the V2 vector minus V1 vector, that is nothing but the delta V. This represents the change in the velocity when the particle passes from the point or moves from the point P to point Q, where delta theta is the displacement, angular displacement. This is also the angle between the two velocities. The numerical value or magnitude or speed of the particle same, that is mod of V1 vector is equal to mod of V2 vector is the V. But there is a change in the velocity due to the change of directions, and we can find out from this triangle what will be the change of velocity. That is the, we know that is V2 minus V1, and from this triangle that delta V is equal to V2 vector minus V1 vector. Now let us proceed. You should understand this figure diagram clearly, because all the statements that will be written on the basis of this figure diagram. Let us V1 vector and V2 vector, already we have stated all these things, and here these are written here. I am reading this. Let us V1 vector and V2 vector be the velocity vectors of point P and Q. The direction of velocity vectors at point P and Q are given by tangents to the circle path at A point and B point. Hence, V1 vector and V2 vector can be represented in the magnitude and directions by the tangent PA vector and PQB vector, because both in magnitude and directions. As the object is moving with uniform speed, therefore we can write V1 vector, that is mod of PA vector equal to mod of QV vector is equal to mod of V vector or V1 vector or V2 vector, that is the V, because the speed is same. To determine the change in velocity of object in time delta t, let us consider an external point, that is the O dash. Let us draw O dash A dash equal to parallel to PA vector, that is V1 vector, and O dash B dash equal and parallel to OB vector, that is V2 vector. And this angle is the delta theta. We already explained it, how we can draw it. That means we can take this is equal to this, because these both are parallel and equal in magnitude. This equal to this, both are parallel and equal in magnitude. And this angle theta, then this angle is the delta theta. If the angular displacement delta theta, then angle between the two vectors is also delta theta. Now, from the triangle law of vector additions, we already have stated that is A dash B dash is nothing but the vector O dash A dash plus A dash B dash is the O dash B dash, and therefore a vector A dash B dash equal to O dash B dash vector minus O dash A dash vector, and it is nothing but the V2 vector minus V1 vector. Therefore, A dash B dash vector is nothing but the change in the velocity, that is the delta V vectors. If delta t is very, very small, then the chord PQ becomes equal to the arc PQ, and the OPQ is considered as the triangle. And in this triangle, when this is very small, that means when delta t is very small, P gradually, Q gradually nearer to the point P. Now this arc will be nothing but the tangent, this type of, and in such a case, we can say this PQO, that is not a triangle, whose angle, this angle is the delta theta. Here, this angle is also delta theta. It is R1, it is the V1, it is the R2, that is the V2. And the value of R1, R2, obviously, these are equal to the R. And this, then we get the angle delta theta, obviously. In triangle, OPQ and A dash O dash B, these two triangles, now let us suppose these two triangles, on which triangles now OPQ and O dash A dash B triangle. In these two triangles, this angle is the common angle, and we can write that is the mod of this divided by mod of this equal to mod of this divided by mod of this, because these are equal in length because their speed are same, and these two are equal in length because their radius value are same. Therefore, these two triangles where delta theta is the common, and this by this one pair of sides proportional to other pair of sides. Therefore, these two triangles, these triangle POQ triangle and O dash A dash B triangle, these two triangles can be said these are similar triangles. And now we can easily say this triangle POQ triangle and O dash A dash B dash triangle, these two are similar triangle because it satisfies the conditions of similar triangles, because one angle is same and one pair of the ratio of one pair of sides of two triangles are equal to 1. Therefore, we can say these two triangles are similar triangles. And from this concept, from the similar triangles, corresponding sides, other sides also will be proportional. Therefore, we can write PQ by OP equal to A dash B dash by O dash A dash. That is PQ from this now, PQ by OP, that will be written A dash B dash divided by O dash A dash. That means this by any side equal to this by any side. Now, if these two are similar one, then any all the sides are also proportional to each other from the property of the similar triangle. So therefore, we can write that PQ divided by OP, that is equal to the A dash B dash divided by O dash A dash. And now, putting the values of these values, that is there is delta PQ is nothing but the displacement, that is a delta S divided by R, and A dash B dash is nothing but the delta V divided by O dash A dash is nothing but the V. Now delta V you can write is delta V, the V by R whole into delta S. And by dividing the time interval, the change taken place in time delta T, by dividing it both sides, the delta V by delta T is equal to V by R delta S by delta T. Then if we here we always consider that delta T tends to 0, then the above equation can be written in this limit delta T tends to 0, delta V by delta T equal to V by R whole into limit delta T tends to 0, delta S by delta T. And it is nothing but the acceleration, linear acceleration, because the rate of change of linear velocity with respect to time, that is linear acceleration. And V by R, that is into, that is delta S by, that is the V also, it is the acceleration, it is the linear velocity, and therefore A is the V square by R. That means at that point V the instantaneous velocity, R is the radius, then what is the centripetal acceleration? Now A will be V square by R, where A is the instantaneous acceleration and V is the instantaneous velocity. We know V is equal to omega into R. Therefore, we can write in this way also the centripetal acceleration or acceleration due to the change the direction. Here we consider only the change in the direction. We are not taking the V changes. That means omega changes. That means it is example of an uniform circular motion. But here we consider due to the change in the velocity, there is a change due to the change in the directions. And we have now one formula for the acceleration or expression for the acceleration. At any point, the acceleration A, that will be V square by R, where V is the instantaneous velocity at that point at that time. And you can obtain another equations also for this. If we put the value of the V equal to omega R, then this equation A will be omega square R also. Equation 3, equation 4 gives the magnitude of the centripetal acceleration of the particle in circular motion, obviously magnitudes, and direction that will be always toward the center. Now, acceleration of non-uniform circular motion. Non-uniform circular motion, there are two types of acceleration taken place simultaneously. Let us say particle is moving in circular path of radius r with uniform angular velocity omega in anticlockwise directions about the axis OZ passing through the center of circular path. Let us suppose here the omega, that is with respect to time, increases. Just one example, when you just switch on the electric fan, ceiling fan, it start to rotate and omega gradually increases. At that time we are saying there will be alpha here. And here we consider it is this plane of rotation, xy is the plane of rotations. Therefore, axis of the circular path, that will be along the z axis in this figure diagram. at any time, let us suppose point A, and after time delta t it reach the point B, and during that there is a angular displacement delta theta r1 r vector for the position vector for the point A, and we considering that omega, that is anti-clockwise order, that means direction of omega along the axis and outwards or upwards, obviously delta theta also along the axis. Now let us the particle moves from position A to position B such that the linear displacement delta r and the angular displacement is delta theta. Now delta r equal to delta theta cross r. Delta r equal to delta theta cross r, just like v vector equal to omega vector cross r vector. Here delta r vector is the delta theta vector cross r. That means this is the delta delta theta vector that is along the axis delta r, and delta r vector, the delta r is the perpendicular to the both or perpendicular to the plane, vertical plane, which contains both d theta and r vector. D theta and r also perpendicular, and d are perpendicular to both delta r and delta theta. D are the perpendicular. Now differentiating both side, dividing both side by dt. So dr vector by dt equal to d theta vector by dt, and which is the v vector equal to omega vector cross r vector. Already we have stated it initially. What is the relation between the linear velocity and the angular velocity? That is the v vector equal to omega cross r vector. This is the vector relation between linear and angular velocity. Differentiating equation 2 with respect to time, if we differentiate this equation, the dv dt, that is the ddt of omega cross r, that is the d omega dt cross r vector plus omega cross dr dt vector, and it is nothing but the alpha vector cross r vector and omega vector cross v vector. Now dv dt is the dv dt is the a vector, d omega dt is the alpha vector, and dr vector dt is the v vector, velocity vectors. Direction of the alpha, omega, and v are shown in the figure diagram. Alpha, that will be along the axis, r will be along the radius, and v, that is the always tangential. Alpha is also along the axis. If the omega increases, that alpha will be along the omega, but when if you switch off the fan, the angular velocity when decreases, alpha will be along the axis but opposite in directions. In such a case, alpha and omega will be not in the same direction, but in this case we are considering the omega gradually increases. Therefore both alpha omega, obviously delta theta, they all these are acting along the axis and in the same directions. Now directions for this along figure diagram. Here alpha vector and omega vector are axial vectors. In equation 3, this equation, in equation 3, resultant acceleration consists of two components. Number one, alpha cross r, that is along the tangent. We take alpha cross r, obviously we get it is r vector that is along the tangents. It is the tangential or transverse component of acceleration. As at is along the tangent to circular path, so this component is used up in speeding up or slowing down the particle. That means this component is the tangential component which can increase the speed or which can increase the change the omega value of the omega. This is tangential component, and it is the mode of alpha cross r, obviously alpha into r into sine of 90 degree. Always alpha and r, these are always perpendicular, therefore alpha into r. That means tangential acceleration will be alpha into r. But here another acceleration also, that is already we have get, that is the centripetal acceleration omega cross v, is the radial or centripetal component of total acceleration. This component is along the radius of the circular path. If you look this figure diagram, there are two components of the acceleration. Resultant acceleration is this, it is not along the tangent or along the radius. Along the radius there is one component, that is AC, that is omega cross v vector, and AT, that is tangential, that is the alpha cross v vector r vector. Now the resultant acceleration will be this. For the non-uniform acceleration, angular circular motion, there are two components, and if there are no AT, then only A will be along the radius, and that will be omega cross v. So in case of omega cross v, what is the mod of omega cross? The omega v sine of 90 degree, because all these are always perpendicular, that is omega into v, and therefore mod of omega cross v, that is nothing but the mod of centripetal acceleration, that is omega v. By putting the omega or value of the v, that means if we put the omega value of the omega, that is the v by r, that will be v square by r, and if we put the value of the v, that omega r, that will be omega square r. The resultant acceleration, that will be root over at square plus ac square. Special cases, if at is the 0, then particle will have only centripetal acceleration. The particle will move on a circular path with constant angular velocity. If AC is 0, the particle will have only tangential acceleration. Now particle will accelerate along the tangent path not remains circular. One, that is the particle now along tangential directions. That means when there is no centripetal acceleration, it will move along the tangential directions. Let to be noted that a centripetal force accelerates the body by changing the direction of the velocity without changing its speeds. That means when there is a centripetal acceleration, there must be a centripetal force. The centripetal force that cannot change the speed, that cannot speed up or slow down the particle. It can only the change in the directions. Now, direction of the centripetal acceleration. Direction of the centripetal acceleration already we know, that is along the radius toward the center. But how can we logically support it? How can you say that it is always acting toward the center along the radius? The direction of centripetal acceleration is same as that delta v. When delta t decreases, delta theta also decreases. So delta v becomes more and more perpendicular to the v vector. When delta t tends to 0, delta v becomes perpendicular to velocity vector. As the velocity vector at any instant is tangent to the circular path, so delta v and hence centripetal acceleration vector acts along the radius of circular path and is directed towards center of circular path. That means the delta v will be perpendicular to the v. Delta v means, in this figure diagram, what is the delta v? We can understand this, and it is the delta v. It is this is the delta v. When this q point, it is the delta v. When the q point very near to the point p, the delta v gradually becomes perpendicular to the velocity vector. And since the delta v perpendicular velocity vector, what is the direction of the acceleration? That is along the direction of the change of the velocity. Therefore, when delta t tends to 0, delta v becomes perpendicular to the velocity v, and since the velocity is always perpendicular to the along the tangent, therefore delta v will be toward the center.